Alrighty, this is a homework tutorial for the geometric proofs assignment. Today I'll work through the odds with you. That means you still have to complete the evens on your own. Alright, for number one, it says given BC is equal to DE, prove that AB plus DE equals AC. So again, no matter the scenario, the first statement will always be your given information. Alright, and then the second reason tells us that they want us to use segment addition postulate. Segment addition postulate is again part equals whole. So when I look at the illustration above, the only line that has two parts on it is line AC. So line AC is the whole, and then AB is one part and BC is another part. So they want us to write AB plus DC equals AC. Now when I compare statement 2 and statement 3, you should notice that the only difference between the two is that BC was now replaced with DE. So when we talk about our properties, the only property that allows replacement is substitution. So BC was substituted with DE. So that was the substitution property. All right, number 3 says, given that segment PR is congruent to segment QS, prove that segment PQ is congruent to segment RS. So again, the first reason, no matter what the scenario, is your given statement. Again, this means congruent. If you look at statement 2, it looks a lot similar to statement 1, except for they removed the bars and the congruent symbol. So statement 2 says the measure from P to R, or the measure of PR, is equal to the measure of QS. So because we told you in statement 1 that the segments are congruent, then automatically that makes sense that the measure is equal, because that's the definition of congruent segments. And yes, I know my handwriting is atrocious, but again, it says definition of congruent segments. All right, statement 3 says PQ plus QR equals PR. PR represents a whole, PQ represents a part, and QR represents a part. So this is an example of segment addition postulate. Now, reason 4 is given, and they told us they want to use segment addition postulate again. So if we look at our illustration, there must be another example of two parts making a whole. And that example would be Q to S represents a whole. So that means QR and RS is another part. So I would write QR plus RS equals QS. Now, in statement 5, we have QR added to both sides of the equation. So that would be the addition property. Now, if I were to take statement 5 and subtract QR from both sides, because they said that the next reason has to be subtraction, then it would cancel out on both sides, which means I would be left with only PQ equals RS. And then since we know, well, PQ equals RS means that the measures of those two segments are equal. So since the measures are equal, that means we can say that they are congruent. So segment PQ is congruent to segment RS. And it's by definition a congruent segment. So just a reminder, when they use a definition as one of your reasons, your setup will look a lot like statements 1 and 2 or 5 or 6 and 7. Statement 1, they gave you the segment piece, the congruent part first, then they gave you the equal part in statement 2. For 6, they gave us the equal part first, or we found out the equal part first, then we proved the congruent part. So it's okay to have it flip-flopped like that, just FYI. Just remember that they go together. So if one of them is blank, you got to remember which one to write next, and then use the correct definition. But it usually will always be this situation like that. All right, and last one, number 5. Says, given angle 1 and angle 2 form a linear pair, the measure of angle 1 plus the measure of angle 3 is 180. Prove that angle 2 is congruent to angle 3. So they decided to write all the given information first. Sometimes they will put everything first, other times they won't. It really depends on the person. So that's, again, they gave us everything out front. Then on statement 2, they give us the reason, and they tell us to use the supplement theorem. The supplement theorem says if two angles form a linear pair, then the angles are supplementary. So we're probably going to look back at statement 1 where we talked about angle 1 and 2 being a linear pair and apply that for statement 2. So now we're going to say that angle 1 and angle 2 are supplementary. Because if you look at your property sheet, or you could write it like they wrote it in number 3, where you could say angle 1 is supplementary to angle 2. Either one is fine. But if you look at your pink paper, that's exactly what it says underneath supplemental theorem. If two angles form a linear pair, then they are supplementary. So that's why we wrote That's why I chose to write exactly what I did on number 2. Now, statement 3 is talking about angle 1 is supplementary to angle 3. But when you go back to statement 1, it shows you that the only thing they talk about with angle 1 and angle 3 is that their measures add up to 180. So we're not going to write supplement theorem again because supplement theorem used linear pair terminology. But if you look on your property sheet again, you'll see the definition of supplementary that says if two angles add to 180, they are supplementary. So this is using the definition of supplementary. So you got to look at some of the key words in those properties to make sure you're writing the correct one. All right, and now we got to fill in the last statement. Well, we've been doing proofs for a long time now. The last statement will always be this prove statement. So we just need to write angle 2 is congruent to angle 3. And the reason for that is because if you look at your pink property sheet, there's the congruent prop supplement theorem that basically says if angles are supplementary to the same angle or congruent angles, then they are congruent to each other, essentially, in the short and sweet version. Well, this concludes your tutorial. Good luck on completing the evens on your own.